Noah.
If it is divisible.
If it is divisible by 6, then Emily, what's my conclusion?
A number is divisible by 3.
Then it's divisible by 3. And it's technically, if a number is divisible by 6, then it's divisible by 3, right? Alright, go on. Alright, I don't want to do that. I don't want to do that either. Okay? We're going to write a conditional statement from the following. The midpoint M of a segment bisects the segment. You guys didn't just see that. Okay? The midpoint M of a segment bisects the segment. So we don't really have if then at all right now, do we? Does anybody have any guesses as to what's the hypothesis, what's the conclusion? Yes.
The
Cool.
hypothesis is if a point bisects a segment, and then the conclusion is then it is a midpoint of that segment.
Okay, we could, if that's how it was worded, then yes. But it's saying the midpoint M. If we know something is a midpoint, what do we know?
It's the middle.
Then it bisects. Okay? If it was worded, if a point bisects, then we know it's the midpoint. But that's not how the question's worded. Okay? It's worded as, this is our hypothesis, and this is our conclusion. So how could we write that? Go ahead, Aylin.
If M is the midpoint, then it bisects the segment.
Good. M is the midpoint, then it bisects the segment. Okay? Write a conditional statement from the following. What do we know? This is why I had you draw that little Venn diagram. What do we know about what is what? What is the hypothesis? What is the conclusion?
Hypothesis is the
Blue Jays. I'm going to do a P. What is the hypothesis?
P.
Okay, sorry. What is the conclusion?
Q.
Which is what?
Bird.
Okay. So, does anybody have any ideas how we could write this as a statement? Sarah, do you have any idea how we could write this as a statement then?
We know birds is going to be after then, and blue jays are going to be after it.
Okay, good.
And if blue jays, then birds.
You're good. You're getting there. Tiffany?
Blue jays fly their birds.
Kind of. Even simpler than that, Lisa.
If it's a blue jay, then it's a bird.
Yeah. If it's a bird, blue jay, then it's a bird. So, yep, you're on the complete right track, Sarah. Or if an animal's a blue jay, then it's a bird. Either way, it works. Okay? Write a conditional statement from the sentence, 2 angles that are complementary are acute, which I believe this is an OYO on your paper. Maybe? Yep. Okay? So write a statement like this. What is P? What is Q? I want you to see it though in an if-then statement. Okay, good, you got it. Good. Flip. Good. Good. Flip. Flip them. Because we could have two acute angles without them being complementary. We could have an acute angle with angle 1 degree, and we could have an acute angle with angle 2 degree. Those are complementary by that. Good. 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 Okay? Think about what you're writing. Yeah, if two angles are complementary, then they are acute. As I was just sharing with Justin, if we wrote, if two angles are acute, then they are complementary, is that a true statement?
No,
Why not?
because they don't add up. They don't have to add up to 90.
They don't have to add it to 90. We could have a measure of an angle that's 1 degree, and we could have a measure of an angle that's 2 degrees. Well, they're both acute angles, but are they complementary? No. Okay, good. All right, so truth value. Sorry. A truth value, okay, and I don't want you to write exactly what this says. I'm going to read it to you, and we'll make our own definition. A conditional statement has a truth value of either true or false. It is false when the hypothesis is true and the conclusion is false. So like in that last one we just talked about, if two angles are acute, then they are complementary. That has a false truth value, right? Because is the hypothesis true? Two angles are acute, but is the conclusion true? No. Okay? So under truth value, to show that a conditional statement is false, you only need to find one counterexample, just like we've done before. One counterexample, where the hypothesis is true and the conclusion is false, like we just did with that problem. Okay? So under truth value, really you can write true or false. And I would write false when P is true and what is false? Q is false. Okay, we're going to determine if the conditional is true. If false, we're going to give a counterexample. If today is Sunday, then tomorrow is Monday. True or false?
True.
True. Is there any time you can ever think of an example that doesn't happen?
No.
If an angle is obtuse, then it has a measure of 180 degrees.
False.
False. Give me an example, Abe.
100
100
degrees.
degrees. Okay? You would have to say, you could say like the measure of angle A is equal to 100 degrees. That's it. That's one counterexample. Proves it wrong. That easy. If an odd number is divisible by 2, then 8 is a perfect square. Okay? Is an odd number, think about the first statement. If an odd number is divisible by 2, which isn't possible.
This could be true because it's like it's
The hypothesis is false.
but the whole
So-
thing is true.
The whole thing is true. Weird, huh? Okay? If the hypothesis, so this whole statement would be true, and you can write that too. If the hypothesis is false, so if the P is false, then whole statement is true. Kind of weird, right? Kind of weird. With that said, we're going to make what's called a truth table, which is going to give you guys a little bit of clues as to whether it's a true or false statement. Conditional. Okay, if P is true and Q is true, we know the conditional is what? True. When do we know the conditional is false? When have we already talked about?
When P is true and Q is false.
When P is true and Q is false. I'm just letting you write a little bit. Okay? How about what's another possibility for P?
False and true.
False and true, which is what we just saw, right? So then what did we see about the conditional?
True.
True. What happens if they're both false?
True.
Also true. So that should give you a little bit of clues to help you when we're looking at conditionals as to whether it's true or false. This hypothesis is never true, right? Can you ever divide an odd number by 2? No, never going to happen. Which means you can look at our truth table and go, okay, it's either going to be this one or this one. But look at that. Is 8 a perfect square?
No.
No. Okay? So it's also false. Which means it's a true conditional. Which is super weird. I don't know. But that's just how it works. Alright? If a number is odd, then it is divisible by 3. If false, give a counterexample. If a number is odd, then it is divisible by 3. And I believe this OYO is all on your paper. Okay, we'll do it anyway. If a number is odd, then it is divisible by 3. Is that a true statement? We can just talk about this. It's alright. Is that a true statement? No, give me a counterexample, Joshua. 25. Give me another counterexample, Ben.
13.
13. Give me another counterexample, Andrea. 17. There's a lot of them, right? They're not divisible by 3. Okay, the negation, and you don't have to, do I have negation on there? Okay?
Yeah.
The negation means not. Really, negation means not. And it's written like this. Not P. The negation, and this is probably something that you want to see. The negation of a true statement is false, and the negation of a false statement is true. Does that make sense? It's the opposite. The negation of a true statement is false, and the negation of a false statement is true. Right? If you don't understand that, write it down. If you do understand that, you should be good. Also, right now, I'm working on, if you guys are absent, I'm going to try and have somebody videotape the lesson, which means it's going on YouTube. Which means if you ever need to go back and watch it, you can. So these notes will be up there. A lot of this is also in your book. Alright, so now we need to talk about the converse. The converse of a statement is found by exchanging the hypothesis and the conclusion. So you switch P and Q. So Q implies P now. That's an arrow. Go that way. Q implies P. Q implies P. Really, you could just say, change the hypothesis and conclusion. Q implies P. Okay? Then we have the inverse. What is an inverse? What's like the inverse of division? Multiplication. So what would the inverse of like P be? The opposite of P, which is what? Not P. Remember? The negation of P. So we have the inverse, which is negation of the hypothesis and conclusion. So not P implies not Q.